This is a capacitor. This is an inductor. This is 3 capacitors. This is multiple inductors. What does this have to do with anything?
No.
This is a cat. And this is everything in a circuit. And what does this have to do with anything?
Everything.
Look down, back up. I'm explaining to you that reactance in capacitors and inductors is a measure of its opposition to AC current with respect to frequency, sometimes known as impedance, but to distinguish between AC and DC circuitry, reactance is used, denoted by X in ohms. Look right, you can hear me explaining that for inductors, reactance is directly proportional to the applied frequency and given resistance, also known as impedance, denoted by Z. Look left, you can see that the major difference between AC and DC circuitry is that AC uses both vectors and complex numbers, whilst providing a magnitude, angle, and a constant frequency. Close your eyes, open them, it's a capacitor. Look again, it's the formula for finding the reactance of a capacitor. How, you ask? Well, I'm glad you did, because I'm about to explain it. Say we are given a circuit with a function generator outputting a frequency of 338.63 Hz. We know that the capacitance of the capacitor is 0.47 microfarads, and so therefore we need to calculate the reactance of the capacitor, being Xc. Now, we know the formula for the reactance of a capacitor is a function of the applied frequency, which therefore gives us 1 over 2 pi Fc, or to simplify further, 1 over Wc. Following this formula, it is as simple as plugging in the values and reading the answer. This means that if we put 1 over 2 times pi times 338.63 Hz, as stated earlier, times the capacitance, which is 0.47 microfarads, an answer for Xc, or the reactance of the capacitor, can be found. When plugged into a calculator, this gives a value of 1000 ohms, rounded to the nearest whole number, which is the correct answer. In a similar fashion, the reactance of an inductor can be found using the formula 2 pi FL, where F is again the frequency and L is the inductance measured in henries. Looking at the previous example again, we can see that the frequency is inversely proportional to the reactance. Look up, back down, the frequency is now 600 Hz. Look again, the value for Xc is now 564 ohms. In other words, the higher the frequency, the less an inductor or capacitor will oppose the current. Close your eyes, open them. You now understand how reactance works, and remember, anything is possible when you go to UAW. I hear a cat.